Across our planet, a silent revolution hums. It is the sound of data, vast quantities of information flowing ceaselessly. This digital tide connects us, informs us, entertains us. It powers our modern lives in ways we seldom pause to consider. From the messages we send to the films we watch, all of it resides somewhere. It is stored and processed in colossal structures, the hidden engines of our interconnected world. These are the data centers, sprawling complexes of technology. They are the very heart of our digital existence. Imagine cities of servers, blinking lights stretching into the distance. Row upon row of machines working tirelessly day and night. They manage the endless stream of emails, the billions of internet searches. Without them, the intricate web of our global communication would simply unravel. But this incredible capability comes with an equally incredible demand. These digital powerhouses are immensely thirsty for energy. How can we sustain this digital expansion without placing an unbearable burden upon our planet's precious resources? The scale of energy consumption by these digital fortresses is truly astonishing. This energy is needed not just to power the servers themselves, but also to keep them cool. For these machines, working at such intensity, generate a tremendous amount of heat. Without constant powerful cooling systems, they would quickly overheat and fail. This dual demand for power, for computation and for cooling, creates a formidable energy footprint. Consider the journey of a single email or a simple online search. It may seem instantaneous, effortless, yet it triggers a chain reaction across networks and servers. Each step consumes a small amount of energy. Multiplied by the billions of such actions occurring every minute, the cumulative effect is enormous. The convenience of our digital tools often masks the industrial-scale operations that support them. This hidden infrastructure, vital as it is, carries a significant environmental weight. The emissions associated with powering and cooling data centers contribute to climate change. The challenge, therefore, is not merely about building more data centers, it is about building them smarter and powering them more responsibly. So what do we mean when we speak of energy-efficient computing? It is a beautifully simple concept, yet profoundly impactful. It means achieving the same or even more computational work using significantly less energy. It is about doing more with less. This approach seeks to minimize the power consumed by computers and data centers. It is a philosophy of smart design and responsible operation. It is about making every joule of energy count. Imagine your own household appliances. An energy-efficient refrigerator performs its cooling task perfectly, but it uses far less electricity than an older, less efficient model. Energy-efficient computing applies this same principle to the digital realm. It encompasses the hardware, the software, and the very way we design our digital systems. It is a holistic approach, looking at every component to find savings. From the smallest chip to the largest data center, efficiency is the goal. By using less energy, we reduce the demand on power plants. This, in turn, can lessen the reliance on fossil fuels. Energy-efficient computing is, therefore, a crucial tool in our efforts to build a sustainable future. The journey towards energy-efficient computing involves several key elements working in concert. Firstly, there is the hardware itself. This means designing computer chips, servers, and storage devices that deliver high performance with minimal power draw. Engineers are constantly innovating, creating processors that can perform complex calculations using a fraction of the energy required by their predecessors. Then there is the software, the invisible instructions that tell the hardware what to do. Optimized algorithms and lean code can make a remarkable difference. Bloated, inefficient software can force hardware to work harder and consume more power than necessary. Clever programming, on the other hand, can achieve the same tasks with fewer computational steps. Beyond individual components, the overall system design plays a critical role. This includes smart power management features. Modern systems can dynamically adjust power consumption based on demand. Virtualization technologies also contribute, allowing multiple virtual machines to run on a single physical server. Every small adjustment, every clever design choice contributes to the larger goal. Section 5, Whispers of Change, a glimpse inside a green data center. Imagine stepping into the heart of a truly modern marvel, a green data center. The air here does not feel frigid, as it might in older facilities. Instead, it is pleasantly cool, managed with remarkable precision. Many green data centers draw electricity from renewable sources. Vast solar panel arrays may shimmer under the sun nearby, or perhaps wind turbines spin gracefully on the horizon, harnessing the power of the breeze. This commitment to clean energy is fundamental. As we venture deeper, we see advanced cooling technologies at play. Instead of relying solely on power-hungry air conditioners, these facilities employ ingenious methods. Some use outside air for cooling, a technique known as free cooling, when the climate permits. Others might use liquid cooling, where fluids circulate directly over hot components, carrying heat away much more efficiently than air. The servers themselves are paragons of efficiency. They are designed to maximize computational output while minimizing energy input. Waste heat, instead of simply being vented, might even be captured and repurposed. This is not science fiction. This is the reality of cutting-edge data center design today. Section 6. Giants of Green. How industry leaders are paving the way. The transformation towards greener data operations is not just a theoretical concept. It is being actively pursued by some of the largest technology companies on Earth. Giants like Google and Microsoft are investing billions in making their vast data center infrastructures more sustainable. They recognize that their scale of operations brings with it a significant responsibility. Their efforts are setting new benchmarks for the entire industry, inspiring others to follow suit. Google, for instance, has been carbon neutral since 2007. They achieve this through a combination of energy efficiency measures and purchasing renewable energy. Their data centers are among the most efficient in the world. They employ sophisticated AI-driven cooling systems that adapt in real time to changing conditions. Microsoft, too, has made ambitious commitments. They are aiming to be carbon negative by 2030. Their Project Natick, an underwater data center, explored the benefits of using the deep ocean's cold temperatures for cooling. These industry leaders understand that sustainability is not just good for the planet, it is also good for business. Section 7. Innovations taking root. The technologies of transformation. The drive for greener data centers is fueled by a constant stream of remarkable innovations. Scientists and engineers are exploring entirely new paradigms for computing and cooling. One exciting area is neuromorphic computing, or brain-inspired computing. These chips are designed to mimic the structure and efficiency of the human brain. The brain performs incredibly complex tasks using very little energy. Neuromorphic chips aim to replicate this efficiency for certain types of AI workloads, promising significant power savings. Liquid cooling technologies are also rapidly advancing. Traditional air cooling has its limits, especially as servers become more powerful and densely packed. Direct liquid cooling, where a coolant flows directly over or through hot components like CPUs and GPUs, is far more effective at heat removal. Another fascinating innovation is the recycling of waste heat. Data centers produce enormous amounts of low-grade heat. This turns a waste product into a valuable resource, a perfect example of circular economy principles in action. Section 8, A Planet's Plea. Why this green shift is so vital. The shift towards energy-efficient computing and green data centers is not merely a technological trend. It is a profound necessity for the health of our planet. The environmental benefits are far-reaching and critically important. Primarily, it means a significant reduction in our collective carbon footprint. By consuming less energy, and by sourcing that energy from renewable supplies, green data centers emit far fewer greenhouse gases. This directly combats climate change, helping to stabilize our atmosphere. Think of the air we breathe. A reduced reliance on fossil fuel power plants means less air pollution. Fewer harmful particulates and noxious gases are released into the atmosphere. This leads to cleaner air, which has direct benefits for public health. Respiratory illnesses can decrease and overall well-being can improve. Experts in climate science and sustainable technology are unanimous in their support for this transition. Green data centers are a cornerstone of this decoupling. They prove that technological advancement and environmental stewardship can go hand in hand. Section 9. Our Shared Future. Embracing the next wave of sustainable tech. As we look to the horizon, the future of data centers and computing promises even greater strides in sustainability. Emerging technologies are poised to redefine efficiency. Modular nuclear reactors, small and inherently safe, are being explored as a source of reliable, carbon-free baseload power for data centers. Artificial intelligence itself is being harnessed to optimize every aspect of data center operations, from energy consumption to cooling, predicting needs and adjusting systems with superhuman precision and speed. This AI-driven optimization could unlock new levels of efficiency. New sustainability standards and certifications are also likely to become more stringent and widespread. These will provide clearer benchmarks for green design and operation. They will empower businesses and consumers to make more informed choices. The journey is ongoing, with continuous improvement as the guiding principle. The digital world of tomorrow will be built on a foundation of even deeper ecological awareness. The responsibility for supporting this green transformation does not lie solely with large corporations or scientists. Each of us has a role to play. The power to shape this future is in our hands.